All right, welcome back everybody. Thank you for taking the time to watch this video. I hope you find it beneficial. Today we are going to be talking about standard RE5, which is our compound exponent rules. And our objective today is pretty basic. It's that you will be able to use all rules of exponents. Now that word all kind of gets intense here because we get some problems where we can tie a lot of different stuff together. I'm going to make two parts of this video. You're watching part one right now. Part one, we're going to go through and just solve all the problems in this column over here. For part two, we'll come back and we'll do some additional practice over there. Part two is optional. Part one is kind of the required video, just so you can make sure you're getting the practice that you need. Now, when we first see this one, so part one says simplify or solve. Okay, so we have a problem, and you may notice we have a couple of question marks in it. A lot of the times those question marks could be thought of as variables if you wanted to, but what we're thinking here is we want to sit there and figure out what number would satisfy those question marks. Now, a couple of things we see here. Right off the bat, we see parentheses. So we're thinking to ourselves, parentheses mean multiply exponents. So looking at this, if I see that I have an exponent of 20 over here, then it's pretty simple to think about what this first question mark has to be. It has to be a 4. Now, let's see here. It's possible one of two things. Either both question marks are going to be the number 4, or each question mark could have a different value. But one thing we know is that this one has to be 4, otherwise this thing won't be 20, right? Because we have to multiply the exponents. Now, if this was 4 over here, so we had 4z to the 5th, all raised to the 4th power, is that equal to 256z to the 20th? So let's see. So 4 to the 4th, right? So since this is 4 to the 1st power, we'd get 4 times 4 as our exponent there, 4 to the 4th. And looking at that, 4 to the 4th power is equal to 256, which is what we wanted it to be. And z to the 5th times z to the 4th would be z, I can do better than that, to the 20th, which is what we wanted to see too. So we have correctly went through and figured out that our question mark in both of these two spots must be replaced with a 4. So in this case, maybe we'd say question mark equals a 4. Let's take a look at this one. This problem's kind of missing. There's nothing to simplify here, so I'm going to make it a little bit more complicated. What if we had this as 3n to the 3rd over 6n to the negative 2? Now, looking at this problem, if this was the problem that I was presented with, we know, hey, we got an issue. We are not allowed to have negative exponents. So if we see a negative exponent, we know we need to pull that to the other side of the fraction. So right now, in the top, or in the numerator of my fraction, I have 3n to the 3rd. If I move that other n to the 2nd to the top, now I have an additional pile of n's up there. And this is all over 6. Now, we didn't need to move the 6 because the 6 has a positive exponent. It has a positive exponent of 1. So, doing a little bit more to this, we can put both of these piles of n on the same pile. Remember, when you have two things with the same base, we just add the exponents together. So I will have n to the 5th. And the last thing we should do is we should always check to see if 3 and 6 can be reduced. We know 3 goes into 3 one time and 3 goes into 6 twice, so we can make this into 1 over 2, which would be our final answer. Moving on, down to the bottom, we get x to the 4th times x to the something is equal to x to the 5th. This is when we got to think a little bit. We are multiplying things that have the same base. How do we get that exponent? And hopefully you think to yourself, well, when I multiply things with the same base, we add exponents. So 4 plus what equals 5? 1, of course. So that means our question mark here has to be equal to 1. Nice job. Let's keep moving along. Here's another problem we're going to be looking at. It says 5p to the 3rd, all raised to the 3rd, times 2p to the 4th. Our job here has to be to simplify. Let's make this as simple as possible. So, looking at this, the first thing we need to evaluate is let's get this. We know that parentheses often happen first in math, so that's what we're going to do here. Remember, when I have a PMME problem, parentheses mean multiply exponents. I need to make sure everything on the inside has an exponent, which is why I went and I put that 1 above the 5. Now when we multiply exponents, I'm going to get 5 to the third and p to the ninth. Now we can make that simpler because we know that 5 to the third really just means 5 times 5 times 5, which is 125. So right now, this whole idea reduced to be 125, but don't forget that is still being multiplied by 2p to the fourth. Now, to do this, we are going to multiply the coefficients, those whole numbers. We just multiply them like we normally would. 125 times 2 is 250. And if I have p to the ninth and p to the fourth, we know that that would give us p to the 13th. And we're done. That's it. Simple as that. Looking ahead at the next one, we have negative AB all raised to the fourth. Again, whenever you see parentheses, ladies and gentlemen, you can use PMME. Now, we got to be a little careful on this one. There's a lot going on here. First thing that I notice is I see that I have this negative in front here. So what I want to do with that negative is let's slide that up in front of the A here. Right? We can slide that either to the A or to the B. We can't do it to both because then we'd have a negative and it'd be positive. So if I slide that negative up there with the A, now let's put in our exponent. So both of those are to the power of 1. And I'm going to put parentheses around that negative and that A because those go together. Now, parentheses mean multiply exponents. So we're going to come over here and we're going to multiply the exponents we see. So we're going to get a negative A to the fourth power over B to the fourth power. Now, looking at that, this is what we need to think to ourselves. If I had negative A, this is the only part that's a little weird is this top. The bottom's great. If I had negative A times negative A times negative A times negative A, if we broke this down into parts, anytime I have a negative A times a negative A, wouldn't that just be a positive A squared? And if I had a negative A times a negative A, that would be a positive A squared. And what we're saying here is we just have A squared times A squared, which of course just becomes A to the positive fourth. So my final answer becomes A to the fourth over B to the fourth. Great job. Let's keep moving along. Here's another problem for us to simplify. I have x to the second over 3y to the third, all raised to the second power. Now again, parentheses mean multiply exponents. Before you can do that, you got to make sure everything on the inside has an exponent. So, coming over here, I'm going to multiply, multiply, multiply. 2 to each of those exponents. Remember, when I do this, the base does not change, ladies and gentlemen. So we are going to have x to the fourth, 3 to the second, and y to the sixth. Looking at that, I can only see one thing that needs to be simplified. I have 3 to the second, and maybe that is better stated as just 9. So let's change 3 to the second to 9, and we are done with that problem. Moving on, here's another one for us. We want to think about this now. So we have negative 4 to the x, or I'm sorry, negative 4x all raised to the fifth power. So we want to sit there. So again, this negative is going with this 4. So I'm going to put parentheses around that to start. That's being raised to the first, and this is being raised to the first. So when I come over here, I need to multiply the exponents. So I'm going to have negative 4 to the fifth power, that's still in parentheses, times x to the fifth power. Now, if I have negative 4 to the fifth power, I can put that in my calculator. Now, please notice how I put parentheses around it. That is very important because if I don't put parentheses, I'm going to get a different answer. Negative 4 to the fifth power is negative. 10,024 x to the fifth. If I would have just typed in -4 to the fourth power, or sorry, to the fifth power, I get negative 1024. This time it ended up being the same, but that's not always going to be true. We got to be very careful when we see those problems. Here's another one for us. Again, we see those parentheses, but notice we got this negative just sitting on the outside. Now here's what we're going to do with that negative. Since all of this is in the parentheses, that is what's being raised to the seventh, not that negative. So we're going to leave the negative for now, and we'll deal with it at the end. Whenever we see parentheses, that's that PMME. Parentheses mean multiply exponents. So now we're going to distribute, distribute, distribute. The base does not change, ladies and gentlemen. So I'm going to have 2 to the 7th, x to the 7th, and y to the 14th. With the negative out front. Now, this could be a good answer for us, right? That negative kind of just drops on down for us. This could be a good answer, but sometimes we're going to see that 2 to the 7th power gets multiplied out. So if I looked at 2 to the 7th, I would get 128. That is my better answer. Let's take a look at another one. 0 to the -3 power. Okay, well, if I think about that, this one's going to get a little strange. Now remember, this has a negative exponent. We don't like negative exponents, you know that. So anytime we had a negative exponent, what we said we could do is you could make it into a fraction, and anything with that negative exponent can get moved to the bottom. Now, if I did that, on the bottom I would have 0 to the 3rd power. And up top, I got to hold the fraction with something, so I'm going to put a 1 there to hold that fraction. Now, looking at this, 1 over 0 to the 3rd. Well, 0 to the 3rd just means 0 times 0 times 0. So I get 1 over 0. There's a problem with that. If I'm never allowed to have 0 on the bottom of my fraction. It's what we say, or it's what we call dividing by 0. And in math, this is one of the big cardinal rules that we're not allowed to break. So if I have 1 divided by 0, let's just see what our calculator tells us here. Divide by 0 error. That's telling us that we're not allowed to do that. So when we see something like this, we are allowed to say no solution. We are not allowed to divide by 0 in math, and that's what's happening there. So we got to sit there and be able to say that there is no solution to that problem. Here's another problem for you to consider. In this problem, notice how we have negative exponents. Again, negative exponents are never okay. Anytime you have something with a negative exponent, though, you can make that exponent positive by moving it to the other side of your fraction. So if I move those two pieces, then we'll be left with 1, x to the 2nd up top, and y to the 6th up top. Notice when those moved to the top, they became positive. And then on the bottom of my fraction here, I'm still going to have an 8. Remember, the 8 did not move because the 8 was really raised to the 1st power, and that's positive, so we don't need to move that. We only move the parts that have the negatives. Looking down at the bottom here, I think we have just a couple more problems left to talk about. We have x to the 2nd times y to the -3rd. Hopefully your red flag is going off and saying this is the part that is not okay. We're not allowed to have negative exponents. Here's how we fixed them. We took our fraction, we put it over 1. Anything with a negative exponent, we move to the other side. So I would be left with x to the 2nd over y to the 3rd. And that's it. Ooh, I think there's a property to remember here, right? anytime I have something raised to the 0 power, remember, this is always equal to, not 0, 1. Anytime we have something raised to the 0 power, it's always equal to 1, ladies and gentlemen. Over here, notice we have 3 raised to the 0 power. That's equal to 1. Those two ideas were being multiplied together. So this is really just 1 times 1, which is equal to 1. That easy. I want to skip this one for a minute, but I do want to come back. There is a type of problem we've not talked about yet. It's this right here. So I want to make sure you're seeing this. If we saw this problem and we encountered this on our test, we got to know how to deal with this. Now, up top, if you notice, we have two things that have the same base. Whenever we have two things with the same base, we need to add our exponents together. So we've gotten simpler, but now, if you notice, we have an 8 to the 12th up top and an 8 to the 3rd on the bottom. Those two pieces, we could get them onto the same pile if we're careful. Now, here's what we know. If we had 8 to the 12th, that's just 8 times 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 8. And 8 to the 3rd is just 8 times 8 times 8. Now, in math, anytime I have the same number on the top and the bottom, I can cancel them off. So how many 8s were left up top? 9. How do we say that? 8 to the 9th power. And that's okay to do. That is the best answer we can give. Now, if I typed in 8 to the 9th on my calculator, if we evaluated that, look how big that number is. Which one looks easier to you? So we'll keep our answer like this. This is much easier to see, to deal with, to work with than 1,300, or not even 1,000. Holy cow, that is 134,217,778. Let's keep our answer like this. Remember, it's another way to think. When we do stuff with exponents, the base doesn't change. It just gets raised to a different exponent power. Last problem we're going to look at. We're going to go back to this column here. Here's what we got to think about. How did we get from the 1 on the left, this guy, to this guy? What exponent made that happen? Now we have some clues here. Often the easiest clue to identify is if you just look at any variable. So right here we had x to the 1st power. And we know that we have parentheses, so we're going to multiply here. If we look at our answer, notice how we had x to the 3rd, but now that's in the bottom. That's unique. So remember, if I had an exponent that originally started up top, then something must have made it negative in order to get it to flip to the bottom. Okay, well, let's think. If that's a positive 3 in the bottom, well, maybe this was a negative 3 up top. And now we just try. Let's just see what happens. If I had 3x to the negative 3, oh, I should write that different. If I had 3x over 4, all raised to the negative 3, we got to check to see if this works. Remember, parentheses mean multiply exponents, so you got to have exponents on everything. I'm going to end up with 3 to the negative 3, x to the negative 3 over 4 to the negative 3. Looking at that, remember, anytime we have something with a negative exponent, it gets moved to the other side of our fraction. So I'm going to have 4 to the 3rd up top. On the bottom, I'm going to have 3 to the 3rd and x to the 3rd. 4 to the 3rd is equal to 64. 3 to the 3rd is equal to 27. And then we have x to the 3rd over here. Notice how these two things are exactly the same. What does that mean? It means that in this problem, our question mark was equal to a negative 3. You got to think outside the box, though, to get there. And that's okay. That's where these problems get that level 4 difficulty for you, right? You really need to think about what's happening. And that's what we're here to learn. Thank you for watching. If you have any questions, please don't hesitate to reach out, guys. Have a good day.